Hello, ladies and gentlemen, and welcome to another wonderful lesson with Mr. Wheezy. So, yesterday, or at least the day before, we'll go with that. The last lesson, we'll go there. We were doing Pythagorean theorem. So, a squared plus b squared equals c squared. A and b being the two sides that are your 90, c being the hypotenuse. So, setting this up, we would do x squared plus 8 squared equals 20 squared. So x squared plus 64 equals 400. Subtract the 64 to the other side. So x squared would equal 336. And we square root that. And that's where we get 4 square roots of 20. No. What did we do there? Yeah. 4 square roots, 21. Yes. That doesn't seem right either. Let's check it. That I'm thinking of a different answer here, and my answer key has the wrong diagram to go with it. So 336. What can we break this down? We'll break it down by 3, which would be 112. 112 you could do by 4. Twice. 28, which would go to, oh my gosh, I was right. Yeah, 4 squared 21. I was thinking right. All right, we're good, because 28 will then go to 4 and 7, so you can pull the 4s out, the 3 and the 7 make 21. Yeah. Sorry, brain fart. Anyways, I blame it on I'm trying to kind of watch the draft and record these lessons, so I should totally dial in. I will focus here. I am sorry, guys. You have my full attention now. The draft can wait. So, getting into special triangles. So, 45, 45, 90 triangle and a 30, 60, 90 triangle are the two special triangles we're going to be working with. Those two are going to be where a lot of our angles come from that we're going to be working with trig. So starting with the 45, 45, 90 triangle. 45, 45, 90 is an isosceles triangle. So that means both legs are going to be the same. So we're going to make those x's. And then the ratio to get the hypotenuse will be x squared root 2. Where that's coming from is all from the Pythagorean theorem. To calculate that, if you want me to show you how that all works, let me know, but I'm going to skip that for now. So pretty much what we're going to do is we're going to take whatever the side is, you can put it for the other side, and take it times square root 2, and that's your hypotenuse. So if we do some of these, like this first one here, our hypotenuse is h. Well, we know h is going to be x squared to 2. Well, this side over here is our x. So that makes this other side 9. And so then h is going to end up being 9 square root of 2. We just put that 9 in for x. So 9 over there, 9 for x to this, and then away we go. Now, this one here gets a little more complicated, I guess you could say. X is going to be our missing side. So the x that we have, so let's call this C actually, so we don't get confused with what's being x and what's not. So our sides being x, that makes this other side 2 square roots of 2. And our last side, since it's x square roots of 2, we would do, for C, it would be 2 square roots of 2 square roots of 2. So when you times that, square root 2 and square root 2 make 2. So c is actually going to be 4. And lastly here, our hypotenuse is 6. So 6 is what's equal to x square root of 2. So if we solve for x, we would divide by the square root of 2. So x is actually 6 over the square root of 2, which we can't have. So we rationalize it and take a times square root of 2 over square root of 2. So 6 square root of 2 over 2 is what that's going to end up being. This we can reduce to 3. So in other words, 3 square root of 2 is what that one's going to be. And so this side is 3 square roots of 2. This other side is 3 square roots of 2. Unfortunately, this one's not necessarily the prettiest when we're working with this stuff because of that square root of 2 in there. But it is kind of nice to know that, hey, whatever the one side is, the other one's automatically going to be that. It's just dealing with that hypotenuse that can be a little bit of a pain. Now, most of the time, in fact, almost all the time, and I'm going to tell you to do this, is leave it as a square root of 2. Don't put in your calculator and get a decimal. Leave it as a square root of 2. It's as far as we need to take it. So the other side of this is then the 30, 60, 90. So our 30, opposite of that's going to be x. Opposite of the 60 is x squared root of 3. And our hypotenuse is 2x. So again, not ideal because we're dealing with a square root. But this one's a little bit easier to work with. Now, there is a proof to this theorem, which pretty much, if we set up the Pythagorean theorem here, if you think about S is this, the full disk, or this over here would also be an S, so each side, this being an equilateral triangle, would be 2S. So S and 2S. And then from there, do Pythagorean theorem of s squared plus, we don't know, squared, equaling 2s squared. So this ends up being s squared plus x squared equals 4s squared. Subtracting s squared over. So x squared would equal 3s squared. And when you square root that, you end up with x equaling s square root of 3. And that's where that's really coming from. So, in order to find the variable or the length of each variable, we're going to run with this. So, the side that we have is opposite of the 60, which is our s square root of 3, unfortunately. So, 5 equals x square root of 3. So, if we solve for x, we divide by the square root of 3. So 5 over the square root of 3 is what's going to equal x. We have to rationalize, so we take it times the square root of 3. So 5 square root of 3 over 3 is what x is. So that makes this side 5 square root of 3 over 3. Now, the nice thing is once you have that short side, you just double it to get this bottom side, which would be 10 square root of 3 over 3. So, really nice when you know this side or the hypotenuse. If you know the hypotenuse, you kind of have to get this. And once you have this, take a times square root of 3 as your last side. If you have this, double it to get the hypotenuse. Take a times square root of 3 for the other side. And the last problem. The triangle is an equilateral, so the altitude divides the triangle into two 30, 60, 90 triangles. So this is similar to what we did with the proof. So the altitude also bisects the base, so that the shorter leg of each 30, 60, 90 triangle is 1/2 s. Now, what it should say is, what is s? Because that's what we're going to find. So, s here is going to end up being, well, if this is x, it'll be 2 times our 1/2 s. That route does not help us at all. However, we do have the side of 1 here, so 1 is going to end up equaling our s square root of 3. So, to get s by itself, divide by the square root of 3. 1 over the square root of 3 is equal to our s, so rationalize it. So square root of 3 over 3 would equal s. Just looking at my notes and making sure that's the question I'm going for answering, because my work does not match that up, and I am sorry, guys. But this should be right. This should be our s. Oh, it should be 1/2 s. So in that case, 1/2 s is that. So if we take it times 2, then that's where I was going wrong, because that compares to this bottom. It's not s. S is there, so you gotta cut it. Or that's actually gotta double that. So times by 2 then gives us s really is 1.154. Well, 5. That's what I'm going for. All right. So that is all for this one here. Questions, comments, concerns, please send me a pan, or email or Google Classroom. Just know that pan is probably the least checked one, so I won't get back to you the fastest. But please let me know if you're having any trouble, especially since I messed that last one up, and hopefully I didn't confuse you too much. I apologize again for that. But until next time, we shall talk to you later.